Okay, so today we're gonna go over distance, speed, and time questions. So the first thing we should go over is like some vocabulary. So a lot of what we will be doing today will relate to rates, which is like a measure, quantity, or frequency, typically again measured against some other quantity or measure. So
Can't hear you.
you can't hear me? Okay. Is this better? Okay. So today we're just going over distance, rate, and time questions. So we'll just go over some vocab first, which is what a rate is. So a rate is a measure, quantity, or frequency, typically one measured against some other quantity or measure. And a unit rate is basically like per every one. So when writing unit rates as numbers, the second number should be one. So like if you've ever like driven in a car, you know like it goes in miles per hour. That's a rate. So it's how many miles it covers in 1 hour. So that's an example of a unit rate as well. And then there's like blinks per second, and then calories per serving, steps per day. So you notice that like for blinks per second, calories, servings, and day, it's all singular. Like there's only one of them. So these are all unit rates. So how to find rates. So first you need to find the unit rate if it's not given already. Put the variable you are multiplying by on the opposite side of the original variable. Add 1 under the second numeric if necessary, and then multiply across. So we'll go over basically how to do this, but these are kind of the steps you'd follow. So if
may I be allowed to copy the units? The units I was copying the first slide you showed.
this one?
Yes, I'm almost done.
Okay. Oh, please don't draw on the screen. Can I move on to the next?
Yes, please.
Yes, yes.
Do you guys want to copy down the steps?
Yes,
I know it
please.
might be like kind of
Yes.
hard to understand right now, but we'll go over
Madam,
one.
please, I'm not yet finished.
Huh?
Madam, please, I've not yet finished the note. I've not yet finished the note. Not this one.
What, this one?
Yes.
I will post the slides after class today, so if you're not able to get everything down, then that's okay. Am I good to move on?
I'm done.
Yeah. Okay. So these are the steps. You might want to note down these steps. So I'll give you some time to do that. Yes, Evangeline.
Please, no.
Okay, are you guys good to move on?
Yes, please. Not yet.
Not yet.
Okay.
Could you send it back to the first slide? I was at the examples of rates.
Oh, that's okay. You don't need to copy that part down. It was just like examples. And I'll also post all the slides after. So if you missed anything in your notes, you can always like look back at the slides. Was everyone able to get all the steps down?
Yes, please.
Yeah? Okay.
Yes, please.
So here, let's do an example problem. So Sue is going on vacation to Japan. She needs to convert her US dollars to yen, which is like what's used in Japan. The conversion rate is 110 yen to 1 US dollar. She has 19 US dollars. Okay, so she has 19 US dollars, right? And we know that 110 yen,
Please, what is yen?
yen is like
Yen
another
is
type of
yen is the official currency for the people in Japan.
yeah.
Okay.
Okay, so there's 110 yen in 1 US dollar. So we know that we need to figure out how many yen is equivalent to 119 US dollars. So there are two ways we can do this. So one way is just how I've written it. So it's like this. So basically the way this works is that you can treat your units like numbers. So when you multiply 119 US dollars times 110 yen over 1 US dollar, you can actually cancel these US dollars. Oops.
Please, I can't hear you.
Oh, okay. Hold on one sec. Is this better?
Yes.
Okay. So what I was saying is that there are kind of two ways you can do it. So one way is you can treat your units like numbers. So if you have 119 US dollars and you multiply by 110 yen over 1 US dollar, you can cancel the US dollars. And then you can just multiply across. Does that make sense to everyone?
Yes.
No.
No? Okay.
Yeah.
So basically, if you like multiply 4 by 3 over 4, you can actually cancel these 4s out because they'll cancel each other out. Does that make sense to everyone? Yeah?
Yes.
Yes.
Yeah.
Okay, so the same thing you can do with units. So, like, if you pretend your units are like numbers, like if this USD instead of being USD was like a number, like X, and this USD was another number X, you could like just cancel the X's out. So that's kind of like the way you would treat this. Does that make sense?
Yes.
Yeah, so then you'd multiply it out, and you get 13,900, or sorry, 13,090 yen, right?
Madam, please,
Do
how
you
did you get the answer?
do you
What?
multiply the 119 by the 110?
Yeah. So because this 119 like no longer has units, because you like canceled out the units, it just takes the units of whatever is left. So if there's yen here, that will be your final unit. Does that make
understand.
So just think of it as like manipulating fractions so that you're able to end up with the correct unit at the end.
Yes.
Okay? So now there's another way you can do it. So the other way you can do it is called using cross multiplication. So you know that some amount of yens over 119 USD is going to give you the same ratio as 110 yen over 1 US dollar, right? Does that make sense to everyone how I got that?
Yes.
Yeah?
Yes.
Okay. So
Yes.
now you can like cross multiply, right? So you have like this. So you get x yen equals 110 times 119. Yeah. So then x equals 13,900 or 90. Yeah. Right? Because you know x needs to be in yen because that's how you set it up before. Does that make sense to everyone how this works?
Madam, please, Madam, please, do you multiply the x times 1?
Yeah, so you cross multiply. So you're gonna multiply, oh my god. Okay, you're gonna multiply this x by 1, and then you're gonna multiply this 110 by 19.
Okay. Okay.
Does that make sense?
Yeah.
So whatever way is easier for you to do it, you can use that way. But there are two ways to do it. Okay. So let's move on. Oops. Okay, there we go. Oh my god. Oh no. Hold on, it's being really weird. Okay.
Madam, please, can you go back to the note we are writing already?
Huh?
Can you go back to the note we are already writing? The
The
one
note?
before.
The ones before the problems?
Yeah. The problem 6.
Do you want me to go back? Do you have a question about the problem or something?
No.
I don't understand.
You don't understand? That's okay.
So
We'll do
please
another.
your answer 3 times it.
Huh?
Don't understand. So please your answer 3 times it.
So
Like
if you
the
don't,
one
if
ten,
you,
like
huh?
the 110 yen and 119 USD. 3 times it to get the 13,090
Yeah,
yen.
so like I was saying before, there's kind of two ways you can do this. So one is using cross multiplication, and then one is using,
Madam, so please I trying to say that in Ghana we have Ghana cities. So our exchange rate is 16 our exchange rate is 16 Ghana cedis. So if our exchange rate is 16 Ghana cedis, and if I had 119 US dollars, and I wanted to convert it into Ghana cedis, I would have to multiply 16 times 199 US dollars, right?
Yeah, so if we like look at kind of how to structure this problem, you want to put like the amount you have or like the number given times the ratio of like um the thing you want to find, like units you want to find.
Why is ratio drawn like that?
Huh?
Can we start writing on the thing?
Please, why is ratio drawn like that?
I haven't finished writing the ratio. Hold on. Units find over units given. Okay, so this is kind of the basic structure, right? You have a conversion rate or a ratio that tells you that the conversion basically between the units you want to find and the units that you are given. So in this problem, you are given United States dollars and you want to find yen, right? So if you want to set up the ratio, our ratio is given right here. So it'd be 110 yen over 1 US dollar. Does that make sense?
Yes.
Yeah? Okay. And then the number we are
Yeah.
given is 119 US dollars. So if we want to find the amount of like 119 US dollars to yen, we just multiply the ratio by 119 times 110 over yen US. And so, because if we treat our units like numbers, we can actually cancel these units and we get 13,090 yen. Does that make sense?
Yes.
Yeah?
Yeah.
For basically like rate conversion problem or something like this, you always want to find what you're given and then what you have to find and then see if there's a ratio you can make to convert the two so that you can get your answer. We'll do another question to hopefully like clear up any confusion anyone might have. Okay, so I'll give you guys maybe some time to try this question and then we can. Oh, let me give you the conversions. Oh, do you guys
Madam, are we answering the question?
yeah.
Is it an assignment for us or you are going to explain it to us?
So I'll give you guys some time to try it, but I want to just explain the conversions. So are you guys
Private message.
familiar with meters and centimeters?
Yes,
Yeah.
please.
Yes.
We learned them at school.
Okay,
Yeah,
so you
they
already
taught
know
us in
the
basic 5.
you guys already know the conversion between meters and centimeters, right?
No.
Oh, that we learned it at school.
Okay, so 1 meter 1 meter is equivalent to 100 centimeters, and then 1 minute equals 60 seconds. So there are the conversions you need.
1 hour equals 60 minutes.
Yeah, but for this problem, you need to do centimeters per minute. So you convert two things instead of one. You need to convert the meters and you need to convert seconds. So I'll let you guys try this and then I can go over one way to solve it.
Private message.
Yeah, please private message me.
Okay, okay. Okay, okay. Okay, okay.
Who is singing? Now this time, most of us are studying. You are singing.
Right. So we can go over the solution now.
Varina, please am I? Varina, please am I correct?
Hold on one sec. Sorry, my slide presentation is being really weird today. So the answer should be 12,000 centimeters per minute. I think some of you guys got a little confused. And you got like 500 centimeters per minute, but that means you only converted the meters to centimeters, but you did not convert the seconds to minutes. So be careful here because there are two conversions.
Please, how do we convert the seconds to minutes?
Yeah, so I'll go over that. So the conversions were 1 meter, 1 meter equals 100 centimeters, and then 1 minute equals 60 seconds, right?
Yeah.
Okay. So the way you want to set this up is that we know our final units need to be centimeters per minute. So let's take this step by step. So in our first step, let's convert meters to centimeters, right? So we have 50 meters per 25 seconds, and we want to convert this into centimeters per second. So we're going to multiply by our ratio that we have 1 meter per 100 centimeters, right? So we want the centimeters to stay, right? So that means we want our meters to cancel. If we want our meters to cancel, how should we set up this ratio? Like what should be on the top and what should be on the bottom? Like, should I have meters over centimeters or should I have centimeters over meters? Which one should I have?
Please, meters over centimeters.
Meters over centimeters.
Meters over centimeters.
Centimeters over meters. And no, meters over centimeters.
Okay,
Over centimeters.
Meter over centimeters. Meters over meters.
so for those of you that are saying meters over centimeters, why are you saying meters over centimeters?
Meter is greater than centimeters.
Because the question says an average of 50 meters. So 50 meters is the main number we are dealing with.
So remember what the ratio is supposed to look like? It's the one you want to find over the one that's given. So in this case, what units are we trying to like find the answer in?
Centimeters.
Yeah, so centimeters should be on the top, and we are given meters, right? So meters should be at the bottom. So our ratio should look like 100 centimeters over 1 meter. Does that make sense to everyone?
Yes.
Yeah? Okay, so we can now cancel our meters out, and we are left with 5,000, 5,000 centimeters over 25 seconds, right?
Please, how is it 5,000 centimeters?
You just multiply this way. So you do 50 times 100 divide by 25 times 1. It's like multiplying two fractions, like if you do like 3 over 4 times 1 half, your answer would be 3 over 8, right? Because it's multiplied. So the same concept applies like here. Does that make sense?
And please, how did you get the 5,000 centimeters?
You multiply 50 times the 100 centimeters to get your answer. Just like 3 over 4 times 1 times half equals 3 over 8.
Yeah. So whenever you multiply fractions, you just like multiply it straight across. So like you do the top number times top number divided by the bottom number times the bottom number. So if you do that in that case, you'd get 50 times 100 over 25 times 1, which is 5,000 centimeters over 25 seconds. Make sense?
Yep.
Yeah? Okay. So now let's do our second step where we convert seconds to minutes. So we have our ratio 5,000 centimeters over 25 seconds. So what should we multiply by in order to convert the seconds to minutes? Should we multiply by 1 minute over seconds, or should we do seconds over minutes?
Please, we are finding
Seconds over minutes. Sorry, minutes over
Minutes
seconds.
over seconds. Minutes over seconds.
Minutes over seconds.
Minutes over seconds.
Okay, yeah. So I think we have to be careful when it's at the bottom because it's going to be 1/seconds. So you have to flip the fraction. I don't know if, okay, the way you could kind of look at this is that if meters is on top, you want meters on the bottom so they can cancel. So if seconds is on the bottom, what should be on the top? If you want to cancel the seconds.
Minutes be at the top.
Minutes.
So if you put minutes here, if I put 1 minute, if I put 1 minute over 60 seconds, does my seconds cancel? I'm still left with seconds, right?
Yep.
So what happens if I do 60 seconds over 1 minute? Will my seconds cancel?
Yes.
Yeah. So now I'm left with 5,000 centimeters over 25, oh sorry, 5,000 centimeters times 60 over 25 minutes, right? Aren't these the units that we wanted, centimeters per minute?
Yeah.
Yeah, so now all we have to do is just plug this into a calculator, say 5,000, or actually write it out, 5,000 times 60 divided by 25, and we get 12,000. Does that make sense to everyone?
Yeah.
Please, is it the 5,000 times the 60 that gives you the 12,000?
Oh, yeah, I can show you how to do the multiplication. So you're supposed to do, so we had 50 times 100 times 60, right? Divide by 25, right? So we can actually cancel out the 25 and the 100. So we're left with 4 at the top. And when we multiply this out, we get 300 times 4, which is 12,000. Or 12, yeah, 12,000.
Okay.
Right? Okay. So just to recap, basically, if you have some units over some other units, if you want to get rid of this unit, it should be across from it. So that you can
Please,
cancel it
can
out.
you go back to the last slide? I want to copy something.
The last slide.
The one before this one.
Yeah. This one?
Yes. Please, the one that you wrote 50
Oh, okay.
times 100.
Yeah.
Thank you.
Okay. So I just wanted to recap something. So when doing rate conversions, you always want to make sure the units you don't want cancel. So if I have like X units over Y units, and I don't want Y units anymore, I just want X units, I should multiply by Y over something else so that
Please,
the Y cancel.
I'm done.
Okay, right? Does that make sense? So even if Y is at the top over X and you multiply, you want to put Y across from it, so you should put Y at the bottom. Does that make sense to everyone?
Please, I can't see.
Oh, okay, hold on. I'm gonna clear the screen.
Yes.
If you have Y units over X units, and you want to find in terms of X units, you always want to get rid of the units you don't want to find. So if I don't want to find y units, then I should multiply by like across by y. So like this, and then put something up here. So that the y's cancel and I'm left in terms of x. And the same thing applies if like y is on the bottom. If I have x over y and I only want to find in terms of x units, I'd put the y across, so I get y over something. And so I'm able to cancel the y's. Does that make sense?
Yes.
Yeah? So you guys can try this one. And then your conversion is given right here. 5,280 feet in 1 mile. And then again, it's like 60 seconds in 1 hour. Oh, sorry, not 60 seconds in 1 hour. Sorry, there's 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So you need to convert from miles per hour to feet per second. So make sure your answer has feet per second.
Madam, please, how do we convert feet into second?
No, you don't have to
I'm
convert
playing.
seconds. You need to convert miles into feet, and you need to convert hours into seconds. Kind of similar to the problem we just did. So take a
Please,
step
how
back.
do you convert miles and feet to minutes and hour?
How
So
many miles make
there are,
1 feet? Please,
oh,
how
here,
many miles?
I can't hear you.
Thank you.
hold on. Okay. So basically, you need to convert your hours into seconds and your miles into feet. So remember, we split it up into like two things. We had two steps. So figure out what those two steps are in order to convert. To make sure that like if you're converting hours, you convert it all the way to seconds and not leave it at minutes. And when you convert miles, make sure you convert it all the way to feet.
So,
Please, you haven't taught me how to convert miles into feet. And how many feet make a mile?
5,280 feet make 1 mile. It's right here.
So it's divided into feet.
If you have a question, I'm just gonna ask to unmute you, so you get that notification. Then you can unmute and ask your question. Just private message me your answer once you get it. Okay, I think this problem was a little confusing, so we should go over it together as a class. So let's start with our first step. We know we need to convert miles into feet. So why don't we start with doing that first? So let's see how to do that. So first, we know that our starting sort of ratio is going to be 60 miles in 4 hours, right? So let's ignore the hours for now and just focus on the miles. So we need to convert miles into feet. So if I want to get rid of the miles and I want to keep the feet using this ratio, how should I set it up? Should I have feet on top, miles at the bottom, or miles at the top and feet on the bottom? What do you guys think?
Miles on top, feet at the bottom.
Okay, so if I put miles on top and feet on the bottom, if I multiply this out, do my miles like cancel? Or do I still have miles? So I'd still have miles because I'd multiply across like this. Whenever you multiply two ratios or two fractions, you just multiply across. So I'd actually end up with like 60 miles squared over 4 hours times feet. Is that what we want? No, right? We want to have feet per hour, right? So how else should we set up this ratio? Should we set it up feet over miles or miles over feet?
Miles over feet,
Over
I
miles.
think.
Feet over miles, yeah. Because when you look at this, you can actually cancel out the miles, right? Because they're on opposite sides of the fraction. So you can cancel these miles out and you're left with feet per hour, right? So that's what we
Right.
wanted, right? So this is what we should do. Okay, so now that we've come to the conclusion that we need to do the number of feet over the number of miles, let's use our ratio. So we know that there are 5,280 feet in one.
Madam, please, I didn't learn ratio in school, so what you're saying is a bit confusing.
Okay, so basically all I'm trying to say is that when you want to convert between units, you just need to make sure the units that you have cancel out, so you're left with the units you want to get. So if I want feet and my ratio is 5,280 feet over 1 mile, we want to cancel out the miles, so we're not left with miles anymore. We just have feet. So that's why you would put it opposing so that you cancel them. Does that make sense?
Yes.
Yeah?
Yeah.
Okay.
Yes.
Madam, please, I'm confused about the 5,280 feet in 1 mile. They haven't taught me that.
Please, I
First,
think I understand that part. Madam is trying to say that 1 mile, like pretend you are going for an outdoor walk, and you set your watch timer to 1 mile. You have to take 5,280 steps for you to reach that 1 mile.
So
That's
does
what
it
I
mean your
understand.
feet, you use your feet 5,280 times?
Yes, one by one.
Yeah,
so
now
a foot is equivalent. Have you guys seen like a ruler?
Yes.
Yeah.
So
So
that
one
the
ruler,
ruler has one part of the ruler has
Exactly.
and the other one has units.
yeah. So let's say this is 1 mile. Okay, this line is 1 mile. So what it's telling you, this ratio, is that it's telling you that each one of those rulers you've seen that have like 12 inches or like, I don't even know how many centimeters, but like each one of those rulers,
A ruler has 30 centimeters.
okay, yeah, so 30 centimeters. So each one of these rulers is going to be put on this 1 mile long line, and it's going to keep going until it reaches the end. And the number of rulers that you use is going to be 5,280 rulers. Does that make sense?
So one ruler is 1 mile.
So, madam is saying that one ruler is equal to a feet. So, example, the ruler is equal to it, and this long line is 1 mile. So, each ruler is representing a feet. So you do like that until you reach a mile. That's the 5,000. So you do it 5,280.
So 5,280 feet is equals to 1 mile.
Yeah.
So 5,280 rulers will make 1 mile.
Yeah, that's what it's telling you. Does that make sense on what the conversion is?
Yes.
Yes.
Yes,
Okay.
please.
So now you're going to use that so that you can get this. Do you guys understand how to convert it?
No.
But how do you multiply the 5,280 feet by the 4 hours?
Okay, wait, hold on. I'll try and re-explain this portion. Okay, so basically, you have your 60 miles over 4 hours, right?
Right.
So now we need to get rid of the miles. We don't want it in terms of miles anymore. We want it in terms of feet because that's what our answer is asking us for, right? So
Right.
how can we get rid of a mile? If we treat the mile as like a number, so if you have miles per hour, and let's say that's equivalent to like 3/4. If I want to get rid of the 4 on the bottom, oh, sorry. If I want to get rid of the 3 on the top, what should I like divide by to get rid of the 3?
4.
Hold on, that's probably making it more complicated. Yeah. So you should divide by 3, right? You want to multiply by 1/3, right? So you can cancel the 3's out.
Exactly.
Yeah. So when you do that, it's like basically the same concept when dealing with units. So if I have 60 miles and I want to get rid of the miles, what should I multiply by?
60 miles. When you get rid of the miles. 5,280.
Madam, please, is the answer 3,800 feet, 240 seconds. Hey, 240 minutes.
So when you do that, you might have got the right answer. So when you,
writing on the screen.
can people stop writing on the screen? Okay. So basically, like when you come up with an answer, if it asks you in like feet per second, you always want the bottom to be 1. You never want any numbers in the bottom. Okay, well, back to this. So what should I multiply by to get rid of the miles? Should I multiply by miles again, or should I multiply by 1/1 mile?
1/1 mile.
Yeah.
Valentina.
Number
Okay,
of a mile.
I'll do, oh, hold on one sec.
Madam. Madam.
He's listening. Just speak.
Madam,
Please,
please, are you going?
student, wait.
Madam,
Please, student, wait.
Yeah, sorry. There is like something happening in the background. Okay. So back to this. I'm gonna try and multiply by something over 1 mile, right? Over a mile. So
Exactly.
yeah, so the units we want to get are
That's
so,
have you written over the mile?
so okay, so now we've gotten that we want miles at the bottom so we can get rid of the miles. But now let's take into consideration what we want to find. We want to find feet. So what should I put on the top so that when I multiply through, I get feet per hour using the ratio?
5,280 feet.
Yeah, okay. So we're going to put 5,280 feet over here, right?
Yes.
Right.
Now this, we can cancel the miles out and we're left with 60 times 5,280 feet over 4 hours, right?
Yes.
Right.
Is this our answer? Are we done with the problem?
No.
No.
Why?
No. You have to convert hours to seconds.
Okay, so now you guys tell me, how should I convert hours to seconds? Or first let's do how to convert hours to minutes. How should I do that?
Mm-hmm.
But won't you multiply the 60 times the 5,280 feet?
Hmm?
Won't you
multiply this.
multiply? Won't you multiply the 60 times the 2 times the 5,280 over the 4 hours?
So basically, I leave it like this so that when I have to compute other stuff, it's like easier for me to like cancel out common factors, which I will show you later. So we're not going to simplify this, we'll just leave it like this. How should I convert
Okay.
the hours? How should I convert the hours? How should I get rid of the hours if the hours is on the bottom? Please stop drawing on the screen.
Stop drawing on the screen. I can't see.
Evangelist, I should stop that. You're distracting me.
Okay. So how should I get rid of the hours on the bottom? What should I multiply by? So here, in order to get rid of the miles, we put the miles at the bottom. If hours is on the bottom, where should we put hours?
On the top.
Yeah. Okay, so we have 1 hour here. So let's first convert to minutes, right? Because in order to get from hours to seconds, we first need to go through minutes, right?
Okay, please, may I answer
Right.
that question?
So we're gonna put 1 hour over, what should I put at the bottom?
60 seconds.
50 minutes.
Yeah, we have to do 60,
60 minutes.
right? Okay, so now we have to do one more step in our conversion. Now I want to convert minutes to seconds. What should I multiply to get rid of the minutes at the bottom?
Um,
Hmm.
to get rid of the minutes at the bottom, you must first
Okay.
What's
to
the
get rid of the minutes at the bottom, you must first bring another here and a mystery number at the bottom. Then, if it crosses, you cancel this minute at the bottom.
Wait, hold on, 1 sec. Wait. Okay, so wait, let's go through this again. So I want to get rid of minutes, right? So where should my minutes go? On the top or on the bottom?
On top.
Yeah, so okay, we know that we want to put 1 minute up here. Okay, So now what do I want to find? I want to find seconds, right? So what should be at the bottom? 1
It's
minute
a
is
minute.
equal to how many seconds? 60 seconds, right? 1 minute is 60 seconds. There's the seconds down there. Makes sense. Hold on. I can't hear you guys because someone has like background noise, and I'm not sure who it is.
It sounds like a TV. If someone is watching it, should move away from that side.
No,
Sorry.
it's okay. Okay. So does everyone understand how this works? Yeah?
Yeah.
Okay. So now we can cancel minutes and minutes. So we're left with 60 times 500 or 5,280 over 4 times 60 times 60, right? So if we were to try to solve this without a calculator, look at how easy it'd be. You just divide, you get rid of the 60s. So then you're left with 5,280 divided by 4 times 60. Okay, so we can actually rewrite this as 528 times 10 over 4 times 6 times 10, right? So we can get rid of the 10s now. So now we're left with 528 divided by 24. So now let's do long division. So we have 528 divided by 24. So 24 goes into 52 how many times? Have you guys learned long division?
Twice.
Twice? Yeah. Okay. So
I don't understand this whole side.
which side? That side? Okay, so
Madam, it goes into 24 goes into 52. Twice remainder 4.
4? Yeah.
Twice remainder 4.
I have 48 and then it goes in twice again, right? So we have 22 feet per second as our answer. Let me just double check. Yeah. Okay. So you're confused about this part? Can I erase part of the screen to go over
Yeah.
this? Yeah? Okay.
Yeah.
Yes.
So I'm just gonna erase this part. Okay, so let's see. Okay, that's good enough. So we have 5,280 divided by 4 times 60, right? So if we wanted to find the factors of 5,280 and the factors of 60, we see this 0 here, right? So whenever there's a 0 at the end, that means something is multiplied by 10. So like this whole portion is multiplied by 10 to give you this number. Does that make sense?
Yes.
0 at the end, so that you can actually break this up. And then you can divide that. And then the same thing happens with 60. So it'd be 6 times 10. That's how you get this portion.
Okay.
Okay. I'm gonna clear all the drawings now. Okay.
Yeah.
Okay. So now we're going to go over speed, distance, and time. So there are certain formulas that are associated with how these relate. So think of it as you're driving in a car, right? So you have a little car here. Here's your little car with its wheels, okay? So the distance the car travels is dependent on not only the speed it travels,
Okay.
but also the time it travels, right? Because the more time you travel, the longer you'll go, like the further you'll go. And the faster the speed you travel, the more distance you'll cover, right?
Yeah.
Yes.
Okay, so this is where we get our distance equals speed times time. So this is like one of the main formulas that you should remember because you can derive the other two from this.
Okay.
So I have distance, which I'm going to abbreviate as D, equals speed, which I'm going to abbreviate as S, and time, which I'm going to abbreviate as
equals S.
Madam,
Mhm.
madam.
Yeah.
So does it mean that if we are traveling at the speed of 48 kilometers per hour,
Mhm.
so does it mean that if we are traveling, so if you are suppose you are traveling from Ghana to US, and the
Okay.
speed of the airplane is 48 kilometers per hour.
Mhm.
So does it mean that the speed depends on the time you reach there?
Yes, because if you look at this, you get speed equals distance divided by time. So speed is dependent on the time, but also dependent on the distance that needs to be traveled. So let's say from like Ghana to the United States, it's 100 kilometers, and you're traveling at 50 kilometers per hour, right? So the amount of time it will take you will be 2 hours. And your speed is dependent on that because 100 divided by 2 gives you 50. Does that make sense?
Yes.
Yeah? Okay. So now we're going to derive the equation for time. So if I want time by itself, I'm going to divide by speed. So I'm going to get distance over speed, right? And then if I want to do it for speed, I get speed equals distance over time. Does that,
Yes, yes.
yeah? Okay, so make sure you copy down these formulas because you'll need them for the practice problems we'll do. So, whoever was asking a question, you were like cutting out, so I couldn't quite hear you. So could you repeat?
But please, who are you talking to?
Huh?
Please, who are you talking to?
I thought I heard someone talking, and then like their voice was like really choppy, so I couldn't hear if they were saying anything. Okay, I guess like if no one has a question, that's fine. Just make sure you copy down the formulas. Oh, and then just like let me know when you're done so we can like, move on. Like, I don't know. Do you guys know how to put the thumbs up on Zoom? Like the thumbs up thing?
Yeah.
Yeah?
Yeah.
Okay. So just do that. Yeah. And just to let me know that you're done copying down the formulas.
What thumbs up?
Huh?
You say
Do you
something about a thumbs up.
do you know where you raise your hand?
Yes, I know how to raise one.
Okay. Just under it, there are reactions. And there's a thumbs up. Do
Yeah.
you see it?
I'm not going there. Yes, I've seen the thumbs up. This.
I like this. I don't understand. Who is asking the question?
I think they're trying to figure out how to do the thumbs up thing on Zoom. If you don't know how to do it, that's okay.
Miss Evangeline has shown me. Thank you.
Okay. Are you guys done copying down the things?
Yeah, I'm done.
Okay.
Yeah.
Let's move on. Oh, I'm gonna clear everything. Okay. So Cece drove for 5 hours and she drove 700 miles. What was her speed? So speed is basically how fast she is moving. So what equation should we use? We're given our distance and we're given our time and we need to find our speed. What equation should we use? It's one of the three you wrote down earlier.
Division.
Please, you for the 5 hours, you use hours, and for the 700 miles, you use.
Okay, so to find the speed is equal to distance over time. So to find this, the speed is okay. To find speed is equal to 5 hours over 700 miles, right?
Close. I think you flipped it. It should be speed equals distance over time. And our distance is 700 miles, and our time is 5 hours. So her
Oh,
speed is going to be 700 miles divided by 5 hours. So you can do this again by like breaking it up into this, divided by 5. So then cross cancel this. So you get, she's going at 140 miles per hour.
Madam, please, can you explain how you got the answer?
Yeah. So remember the formula we had before? You know,
Yeah.
this speed
Speed
equals
is equal to the
distance.
distance given.
Yeah. We just use that here. And you need to figure out what your time is and what your distance is. So distance is always in units like miles, kilometers, meters, stuff like that. And time is always in the units of like hours, seconds, minutes, you know. So you can easily find out what distance and time is here because 700 miles is a unit for distance, and hours is a unit for time. So you're given distance and time. So then you just plug it into the formula, speed equals distance over time, and then you just solve for it. Does that make sense?
Okay. Yeah,
Okay.
makes sense a lot to me.
Okay. So yeah, your answer is 140 miles per hour. So you can either write your mile, like your units. Okay, always put units for these questions. Like always put units.
Madam,
Please, a question.
please, I want to ask the class a question.
Yeah.
I want to ask the class this question. So what if CC drove for 7 hours and drove about 1,000 miles? So what would be the speed?
So you
She
know
drove
that.
for seven.
is it CC?
She drove for 7 hours
Mhm.
and drove for 1,000 miles. So what would be the accurate speed?
It'd be 1,000 divided by 7 miles per hour.
Please, I
Because
have
Okay.
a question.
does that make sense though? Why?
Yes.
Please, a question.
Yeah, ask your question.
Please, is this 70?
Yeah, that's 70.
Okay, thank you.
Do we understand how to do this? Make sense?
Yeah.
You just like, plug stuff into your formula. Okay. So make sure you always put units on these answers. And I know this might look a little different from this, but it's the same thing. So you can like, I guess like one way to write it is like, so you say this as miles per hour. So you can just put like mph, like so that stands for miles per hour as well. But you can also leave it in the fraction form. That doesn't matter. Okay. Do you guys want to try this question? It might be a little more difficult, but I feel like it's a good question. So, a plane flew 9,000 miles. So, what is 9,000 miles then? If a plane flew 9,000 miles, is it S, D, or T?
Madam, please, what's the meaning of PST?
Yeah.
PST? Oh, this is a time zone. So, you know how you're in like the Ghana time zone?
GMT.
Yeah, I'm in PST. So, I'm on like Pacific something time zone, Pacific
Oh,
Standard Time Zone or something like that.
okay.
So it's just telling you like what time of day it is. Okay. So if a plane flew 9,000 miles, what is 9,000 miles? Is it Speed, distance, or time?
Distance.
Yeah. Okay, so let's label that as distance.
Distance.
Okay, so we have that as our distance. It started at 5:30 in the morning and it landed at 7 p.m. in the same time zone. So, do you guys know how to find the difference in time? Like
No.
how long it takes from 5:30 to 7?
No.
Okay, so I'll just quickly go over that. So, like, let's say we have a clock. So it goes 6 here, 5,
Madam,
4. Yeah,
madam.
yeah.
So doesn't mean it flew for 13 hours, 30 minutes.
No. This means it flew for like 14 and a half hours.
Okay.
Hold on, I'll go over how to get that like right now. This clock is kind of ugly, but that's okay. Okay, so we have this clock, right? So we start at 5:30. So let me just draw our hands. So we have 5:30, right?
Right.
Okay, so let's first make sure that 5:30 becomes like a whole number, I guess. So let's make it 6. So we have 30 minutes, right? To make this 6. So now we start at 6 instead of 5:30. Okay, so from 6 a.m. to 6 p.m., how many hours are there?
12.
Yeah, so there are 12 hours, right? So now we're
Yeah.
gonna put plus 12 hours. So um we have reached 6 p.m. now. Okay, so now what's the difference between 6 p.m. and 7 p.m.? It's 1 hour, right?
Yeah.
So we're gonna add 1 hour. So we're gonna get 13 hours and 30 minutes, right? So yeah, it is kind of close to 13, I guess. So yeah, so now this is how much time the plane flew, right? Because it's in hours and minutes. So now what is the speed of the plane in miles per minute, right? So you need to do two main things.
That is something I think I know.
So you need to do two main things. First, you need to make sure the time has a consistent unit. So let's convert time into minutes first, right? So how many minutes is in 1 hour, right?
60.
Yeah, so there's 60 minutes in 1 hour. So let's convert 13 hours times, what should my ratio be? It should be 60,
13.
30 minutes.
wait, 60 minutes over 1 hour or 1 hour over 60 minutes?
60 minutes over 1 hour.
Okay, so we'll do that.
60 minutes per 1 hour.
Yeah, so we can cancel the hours. And so we get 13 times 60 minutes plus 30, right? So this gives us how much? Let's do 13 times 6.
13 times 60.
780 plus 30. 810 minutes, right?
Yeah.
Yeah?
810 minutes.
Do you guys understand how I got 810 minutes?
Yeah.
Yeah? Okay.
Yeah.
Okay, so now we have our time is 810 minutes. So now what should our answer be? It should be, so we want to find the speed, right? So what is speed?
Speed is distance divided by time.
Yeah, okay. So we know our time is going to be 810 minutes. Or sorry, our distance is 9,000 and our time is 810 minutes. Okay. So you can't actually report speed like this, or like in this case, because it's asking you for a decimal number, right? Because it's telling you to round to the nearest tenth. So before we divide everything, is our units correct? So this problem is asking for miles per minute. Do we have miles per minute?
No.
Why don't we have miles per minute?
There we have.
Do we have it? Or do we not have it?
Hello.
We have.
We have miles per minute? Yeah. Because it's miles over minutes, and that's what miles per minute mean. Okay, so now let's divide 9,000 by 810. So first let's simplify. So we know that we can get rid of the tens, right? We can get rid of the tens, so let's cross out the zeros. Okay,
9,000 miles.
What happened?
810 miles.
Madam, this is what I think.
huh?
This is what I think.
Wait, there's a lot going on. Okay.
Please raise your hand if you have a question.
Please, I have a question.
Yeah,
Like,
You said that the zeros were cancelled. I don't understand.
wait, hold on. Can everyone stop drawing on the board for a second? Okay, who had a question?
no one. Please.
No one had a question? Someone said they didn't understand. So who didn't understand? No one didn't understand? Okay. Wait, hold on. Wait, guys, don't draw on the
Stop.
don't draw on the board.
You know.
Green.
Okay. So
Madam, can I please? Earlier.
but I can't hear you. Whoever is asking a question, I can't hear.
Madam Varini.
Mm-hmm.
Madam Varini.
Yeah? Yeah, with the question.
Who is asking the question?
Madam,
Leah.
we came late, so we don't understand what's going on.
Okay, yeah. I can re-explain. Does anyone else have a question? No?
Yes,
Okay.
I said I have a question.
Yeah?
The fact that it said the zeros were cancelled, I don't understand.
Oh, okay. So basically, remember you can represent like anything with zeros as like multiplied by 10. So you get like this, right?
Yes.
So you can actually just cancel out the tens and that'd be like canceling out the zeros. Does that make sense?
Yeah.
Okay. So basically going back to the question of like where I was re-explaining. So we have this formula called distance equals time times speed. So we use this formula for everything. So in our problem statement, we just want to figure out what each of these components are. So we know that 9,000 miles is going to be our distance. And we know that our time is going to be the difference between 5:30 in the morning and 7 p.m. at night. So we found out that the difference between 5:30 in the morning and 7 p.m. at night is equal to 13 hours and 30 minutes. But we want to convert all of the 13 hours so that there are in minutes as well. So when we convert it, we get that there are 13 times 60 hours plus 30 minutes, which gives us 810 minutes. Does that part make sense?
Yes.
Yeah? Okay.
Madam, please, I still don't get it.
What part do you not get? Is it the time part or like the formula or like what part do you not get?
Please, it's the formula.
Okay. So think of it like you're driving in a car. that's a really ugly car. Okay, think of it, you're like on a car on the road, right? So the amount of distance you travel is like dependent on how much time first you're driving for and the speed at which you're driving at, right? Because like the faster the speed, the more distance you travel. The more time you drive, the further distance you travel. So that formula is like what gives us this. And we can rearrange this formula to solve for speed, which is what we use here. So we get speed equals distance over time. Does that make sense?
Yes.
Thelma, does that make sense? Okay, I'm just gonna take that as a yes. Okay, so let's go back to simplifying. So now we have 900 over 81, right? Well, there is still one other common factor. Does anyone know what the common factor is?
I think it's 9.
Yeah, it is 9. So we can write 9 times 100, and 81 is actually 9 squared, or 9 times 9. So we can do it like this, right? So we get that this whole expression, 9,000 divided by 810, is actually just equivalent to 100 over 9. So now we can just do our long division, and we can find that
Join the screen.
our answer is just 11.1 miles per minute. Does that make sense to everyone?
No.
No? What part did it make sense? The division part?
Yes.
Have you guys learned long division?
Some of us.
Okay. So basically in long division, all you're trying to see is that what can I multiply the outside term by to subtract like from the first two numbers in the inside term. So if I have 9, if I have like, if I have 100 apples, how many can I give to each person? That's kind of what long division is. So, yeah. Okay. So when you try to find out how many apples you can give to everyone, you find that the maximum amount of like whole apples you can give is 11 because 9 times 11 is equal to 99. So that means you have one apple left. So then it'd just be like 11 plus 1 over 1 over 100 and then stuff like that. So, does that make sense to everyone? Kind of like how we got here? Oh, yeah, okay.
Madam, please, can you erase the distance here? Because someone is writing unnecessary things. It's like
Yeah.
it's even
I can erase.
just writing on the screen and I can't see.
And drawing.
Is that better?
Yes.
Okay. Zelda, do you have a question? Okay. Evangeline, do you have a question?
No.
No? Okay. Okay. Does anyone have questions on this problem?
Please.
Madam, please, now what is the final answer?
Oh, 11.1 miles per minute. Yeah, there. Well, it's kind of like middle of my work. That's okay. Okay, no more questions? Okay, we'll move on then. Okay, so there's something called velocity and there's something called speed. So try not to get confused with these two because they mean very similar things. So speed is how fast you're going, but there's no direction. So like if I have the airplane here, my speed is just telling me that it's moving at 100 kilometers per hour, right? But I have no idea what direction it's moving in. If I have velocity, velocity has a direction. So it's telling me that this airplane is actually moving to the left at 100 kilometers per hour. Make sense? The difference? And so velocity is just like how much you change over time. So like if I'm traveling a distance at a constant rate, it's just basically how fast I'm moving. That's my velocity. So if you come back to your original spot, your velocity would be 0 because you didn't move basically. Okay. Does that make sense to everyone? So velocity has direction and speed does not have direction. Good?
Yeah.
Yeah, I'm good.
Sharon is at a swim tournament. She swims 200 meters in 1 minute and 15 seconds. One way across the pool or one lap is 25 meters. How many laps did she take? What's her speed and what's her velocity? So we'll go over this question together.
Please, I was writing what was there before.
What? Okay,
The
so
I was writing the first one, then you left that slide.
oh, sorry. You can ignore this part. This part is not relevant to anything. So I'll just
Okay.
just do this. You do not need to copy that part down.
Then I'm done.
Good? Okay. Let's move on then. Okay, back to this. So she swims 8 laps. Her speed is what, 60 meters per minute? Or 267. Okay, so notice that her speed does not. Okay, so notice that her speed is within minutes or meters per minute or meters per second because the problem didn't actually tell us how we should do it. Should we do it in seconds or should we do it in minutes? So you can basically pick here which one you want to do. So I'll just show you both of them. But yeah, but in this case, also note that her velocity is the same as her speed. Like she's moving at the same rate. Like velocity is just speed with direction. So in this case, her velocity would be like 2.67 meters per second forward and then 2.67 meters per second backwards. But because she's going at the same rate in both directions or like in opposite directions, her velocity is just like it like cancels. So her velocity ends up being just 0. Does that make sense? It's a little confusing.
Yeah.
No.
Okay, so basically what I'm saying is that she's going this way at like x meters per second, and she's also going this way at x meters per second, right?
Right.
Because she goes back and forth in the pool. That's like how you swim, basically, right? So
Right.
okay, so then let's say one direction is like our positive direction. So let's say this way is our positive direction, right? So that would mean when she goes this way, when she goes forward, she has a positive velocity. But when she turns around and goes backwards, she actually has a negative velocity. Does that make sense?
Yes.
She's going opposite the positive direction, which should be the negative direction. So then when you want to find her total velocity, because she's constantly changing her direction back and forth, these velocities actually end up like canceling each other. So her overall velocity is just 0. Because like for the whole time, she's just going back and forth at a constant speed. Does that make sense? I know it's a little
Yes.
confusing. So
Yeah.
basically, if she was only going forward, her velocity would also be 2.67 meters per second forward. But because she's going forward and backwards, her velocity, like, it keeps going positive and negative, so it like keeps canceling each other out, so it ends up being 0. That's basically just kind of how it works.
Yeah.
I know it's a little bit complicated, so if you have any more questions, just feel free to ask, and I'll try to explain it to the best of my abilities. But this is kind of advanced, so it's okay if like there's a little confusion. Okay, so now that we've come to the conclusion that her velocity is 0, let's figure out her speed. So the speed at which she goes, or the speed at which she like does the laps is okay. So first let's find out how many laps she swims. So we know that she swims 200 meters in 1 minute and 15 seconds, right?
Right.
So how many laps would she swim? If we know that one lap in the pool is 25 meters. So we know that we have 200 meters in, let's find a constant unit. So let's do seconds because we want to just have a constant unit. So that there are 60 seconds in 1 minute, and 60 plus 15 is 75 seconds. So we have 75 seconds here, right? Everyone get that?
Yeah.
Good? Okay. So we know that one lap is 25 meters, right? So let's set up a proportion here, because it would be easiest to do a proportion. So we know that 25 meters will take X amount of seconds, right? Does this proportion make sense? Because the rate at which he crosses one lap, it stays constant throughout the whole like race, I guess. And so the ratio at which she'll finish 200 meters is going to be equal to the ratio at which she finishes 25 meters. Does that make sense? Yes, no. Do you guys understand what I said? Like their ratios are equivalent?
Yes.
I understand.
Yeah? Okay. So now let's cross multiply. So we're going to multiply 200 times x equals 75 times 25, and we're going to divide by 200 to get x alone. So we get x equals,
Yeah.
this can be written as 2 times 100, so then 4, then it's 75 divided by 8.
Madam, please, can you go over again? My connection isn't stable.
Oh, okay. You want me to go over how I set this up? Okay, so basically, if she goes 200 meters, so
Yes,
let's say she
please.
200 meters. If she does 200 meters, the rate at which she finishes the 200 meters, so like the distance divided by time, it's the rate at which she does the 200 meters is going to be equivalent to the rate at which she will finish one lap because she's moving at a constant speed, right, throughout the whole tournament. Correct? So we can say that these two are equal because their ratios should be equal. Does that make sense?
Yes.
Evangeline, please stop joining the screen.
Okay. So now we're going to do the
Yes.
cross multiplication. So we're going to get 75 times 25 equals 200 times x, and I just divided by 200 to get x alone. And then just to save some time, I'm going to put this in a calculator. Hold on, 1 sec. Did I do something wrong? Okay, hold on. I think I made a mistake somewhere. Sorry about that. Let's try this again. Okay. So actually, let's start out by finding how many laps she swims, because we know that she does 200 meters, so the number of laps she'll swim is going to be 200 divided by 5, right? So number of laps equals 200 divided
Marcus,
by...
how come you are dividing it by 5?
Huh?
Please, how come you are dividing it by 5?
I'm not dividing anything by 5.
No, I mean like the 200.
Oh, I'm dividing by 25 because I know she swims 200 meters, right? And we need to find out how many laps she swam, and we're given that one lap is 25 meters. So if she swims a total of 200 meters and each lap is 25 meters, you just need to figure out how many 25s fit in 200. Does that make sense? Because then you
Yeah,
can how many
yeah, a
laps.
little.
Yes.
Okay, so once we got that, now let's try and find out her speed.
Yes.
So we know that she does 200 meters in 75 seconds. So let's see. So we can just do this. We have 200 meters in 75 seconds. So we can actually just divide this. We can just divide 200 by 75 because they have not given us units in the problem. So we can put units in whatever units we want. So if our units are meters per second, well, our fraction is already in meters per second. We can just do 200 divided by 75 to get 200.67 meters per second. Does that make sense?
Yes.
Okay. And then we've come to the conclusion that her velocity is 0 because she keeps going back and forth, so it cancels out. Okay.
Please stop writing on the screen.
Let's go.
Roger.
Oh, I think my thing froze again. Hold on 1 sec. Oh, okay. I think that's the last question then. So does anyone have any questions or anything?
No, please.
No? Okay. Do you guys want to do a couple more like practice problems for the unit conversions? We can go over
Yes.
them.
Yes.
My connection.
So
My
let's
Able.
okay. So let's say Katara, instead of driving 60 miles, she drives 100 miles. She drives 100 miles. And
Yes.
not every 4 hours, let's say she does it every 10 hours. So convert that into feet per second. So remember, I'm not going to give you the conversion from hours to minutes to seconds. Let's see if you can get it. So set up your proportion or like your multiplication thing, and then private message me your answer.
Usuwa. Your network.
Okay, so just like try this question and then private message me your answer.
Your screen is glare.
Hmm?
Screen is glare.
Do you guys know how to do it? Oh, okay, there we go. Are you guys trying the problem? Or do you guys like not know how to do it? Because that's okay too.
We know. Hello.
Yeah. Yeah. No, this.
Oh, I just said to attempt this problem and then just private message me your answer. Okay, well, I'll go over the answer because I think there's still a little bit of confusion. So, okay, let's go through this together. What should my first step be? Who knows what my first step should be? What should I convert into what first?
Convert feet into second.
Feet into second? Wait, you can convert feet into seconds. So I think maybe you wanted to say like convert miles into feet. So remember, you have to stick with like distance to distance and time to time. You're given miles, you cannot convert miles into seconds or hours, but you can convert miles into feet. You can't convert hours into feet, but you can convert hours into seconds. So let's first do that. We have 100 miles in 10 hours, right? So if I want to convert from miles to feet, what should be at the bottom and what should be at the top using this ratio?
At the bottom, it should be 1 mile.
What should go on the top?
$5,280 feet.
Yeah. We have 5,280 feet here. Right? Okay, so now we can cancel out the miles. Okay, so now our next step is going to be convert the hours into minutes and then seconds. So how do we convert the hours into minutes? If I have hours at the bottom, where should my hours be? What should my ratio be? Should it be like minutes over hours or hours over minutes? Come on, guess, guys. You have a 50-50 chance of getting it. What do you guys think it should be?
Hours over minutes.
Yeah, it's hours over minutes. You guys know why?
Yes.
You can cancel the hours, remember? You can cancel it now, and now you're left with minutes. Okay, so now I want to convert minutes into seconds. How should I convert minutes into seconds? What should my ratio be? It's very similar to the hours over minutes one. It should be 1 minute over 60 seconds, right? So now the minutes cancel. So you're left with 100 times 500 or 5,280 times, or sorry, divide by 10 times 60 times 60, right? So if we multiply all of this out, 100 times 500 to 8, divide by 10 times 3,600, we get 14.67 feet per second. Does that make sense?
Yes.
Okay. You guys will get more practice on your homework, so yeah. But yeah, that's it. Sorry for keeping you a little longer, but yeah. Okay. Thank you all so much. See you next week. Okay.
Bye.